So this is just the introductory lecture to the MTA, the first one this class is having. So yeah, I'll start by just describing some of the details. I hope you can all see my screen. If you have any questions or anything, then you're welcome to ask them in the chat. So yeah, let's get started. Actually, I will minimize this because it's taking up too much of the screen. Okay. So yeah, welcome everyone. So yeah, the first thing I I assume, like probably the entire course will be held online. I'm not sure what the sort of timeline is on. I don't think anyone is on this whole pandemic, so I'm not sure if we'd ever be doing this in person. I will be uploading all of the lectures to YouTube because yeah, I know like Saturday morning is maybe a bit of a weird time, and just in case anyone has like important plans, you don't have to worry, you'll be able to catch up anytime during the week. So yeah, online lessons will be held on Zoom. We've done some experimenting with the other Brighter Futures classes, and yeah, we found Zoom that is the most consistent, and most of the students usually say that the audio quality is best on Zoom compared to all the other platforms we've tried. And yeah, so time is short. This class is like I said, an interesting challenge because the curriculum is set out to start, I think, in the sort of March period usually. So we're way down on time, but it things should still go smoothly. So that's good. And yeah, what we'll be learning in the course, I will be sort of hurrying through introductions, and we'll be getting right into things. So the first thing and the main thing I like people to get from this course is to just learn to think programmatically. So to learn to think more like a computer, if you like, and just improve your intuition about how computers operate. The next most important thing is to learn a little bit about how to use C#, and we'll try to keep those skills as generalizable as possible, so you'll be able to transfer them to other programming languages as well. We'll learn about general software development and how it occurs in, real companies and startups and the like. And the other very important thing is, of course, to pass the test. So because this course is happening at a bit of a weird schedule, we're not exactly sure when the test would be. The other classes are set to write at the end of November. If we can meet that schedule, then obviously that's great. If not, then we would have to discuss with the class and see when everyone could write. So yeah, I don't know if you guys have any questions. I think we will pass. Apparently, load shedding is scheduled to start now again, so I'm glad that my power's not out. Cool, things are going smoothly. I hope you're all still here as well. Anyway, so. Yeah, I don't know if there's any other questions you have just about the structure of the course. The other thing is Arthur, I reshared it on the WhatsApp group now, just before the lecture started. There is a PDF there that is the first chapter of the textbook, which usually you would have received a hardcover copy of by now. But obviously, given the circumstances, that probably hasn't happened. So you can follow along in the PDF. I will occasionally reference it, and obviously it's a fantastic study resource as well. So yeah, without further ado, let's get into things. So I think the most fundamental topic in software development is really the algorithm or the procedure. And I think probably most of you guys already know what an algorithm is, right? It's a set of steps to achieve a particular goal. And so we'll sort of skip the formal definitions of algorithms since it's fairly simple, and rather go immediately into the ways in which we display them and think about them in a way that is relevant to actual software development. So the way that we depict and display algorithms are called decision structures. So this is just a formalized way for us to display how decisions are made. Like you as a human being might have a specific intuition about how a specific thing occurs, but you'll usually find that the actual procedure for achieving that goal is vastly more complicated. So let's stop discussing it on a theoretical level and actually see some of these. So we'll be talking about 2 decision structures in this course. There are many others in the world, but we'll just be discussing 2. They are flowcharts, and you can see a flowchart on the left there, and decision tables, and that's a decision table on the right. Now, both of these we will be going through in more detail, and we'll also, yes, I see someone's discovered the annotations. It's very useful. Some of the students, when we started using Zoom, got a bit carried away with them, but they are very cool. If any of you want to highlight a particular part of the screen or very quickly ask a question, like you can just put a question mark over a specific point on the slide, and I'll go ahead and answer as best I can. So flowchart on the left, decision table on the right. Those are the 2 decision structures that we're going to learn how to use. You'll see they're fairly straightforward after you know how to read them. Okay, so cool. Let's start with this flowchart. It's a bit of a jokey example of a flowchart. This is a nice flowchart to have when you're stressed. We'll see a more technical one on the next slide. But this will help us come to grips with the most basic part of a flowchart and hopefully be less intimidated about thinking in a programmatic way. So the point is we want to get from the sort of start to the end and achieve a particular goal in between, okay, in between the start and the end. And we just want to encode in steps how to achieve that goal, basically. So, cool. So let's just think about what this flowchart is doing on a general level. Okay, so probably the easiest part to get about it is where to start. Okay, so they make that fairly clear, and this will always be clear in all programming languages, in all algorithms. It needs to be very clear where the start is. So we go to the start. And you just follow the arrows. Fairly straightforward. You'll see that these can get substantially more complicated than the one we have on the slide now, but it's the point is just attaining a general view of them. So we go to the first step. Do you have a problem? Okay, and you can see that diamonds, and hopefully you can immediately tell, diamonds are encoding a actual decision. So remember, we've referred to these as decision structures, and the primary thing that they're doing is encoding how to flow out of decisions, right? And as you guys also probably know about computers, is we usually encode things there's always only 2 options at most, right? 0 or 1, true or false, yes or no. So you can see with these diamonds, if you come to a diamond, it means you have a question, and they're always going to be yes or no questions, right? Like, do you have a problem? Yes, I have a problem. No, I don't have a problem. Okay, if you don't have a problem, you follow the no path, you get to don't worry. If you do, you go to yes. The next question, so we've come to another diamond, so it asks another question. Can you solve the problem? If the answer is yes, then you don't have to worry. And if the answer is no, then you don't have to worry. And then we get to the end. Okay, so that's a simple depiction of a flowchart, but the important things that I want you guys to get so far is just the shape of these various parts of the flowchart. So ovals define the start and the end of your flowchart, or the sort of ovular shape. I'm not sure if that's the technical term for it, because obviously it's got these flat sides. But that is what they look like. Diamonds for decisions, and they do call them ovals, so don't worry about that. So diamonds for decisions, as we discussed, but always remember yes or no, because that's how computers encode decisions. But you can see you can chain on. We do have 3 possible outputs here, right? Do you have a problem has no, can you solve it has no, and yes, right? So there are 3 branches to this final step. But each decision only has 2 options. So by chaining a lot of decisions together, we can make more complicated decisions. But yeah, a diamond will encode a single decision. This rhombus shape, so like a square but slightly diagonal, is for what we call input and output. You might not have a good intuition about what input and output is yet, if you're not familiar with computer lingo, but we'll discuss it more in detail later on in the course. So that's the thing I want to encode with this first flowchart, is just what all the different shapes mean. And now we'll move on to the second one, but before we do, I think it might be worth just giving you an example of the kind of problem that we might encode in a flowchart. So actually, I'm going to go back a bit so that I have a clear slide. Someone, you have a little bit of background noise, if you wouldn't mind. Okay, so quickly, I'm just going to do an interesting thing. So I'm going to draw out one number, and then I'm going to draw out another number, all right? And what I want you to do is, when you see the second number, and you can say it out loud. I mean, maybe I wouldn't hear you if your microphone isn't on, but you could also type it in the chat, or just visualize it to yourself. I don't necessarily have to hear. But the idea is that you're just going to say which number is larger. All right, you're just going to say which number is larger. So forgive my handwriting. I am writing this with a trackpad, so it will be quite awful, I assure you. But the idea is, we've got one number that is a 3, in case my handwriting is too bad for you to be able to tell. And I'm now going to draw another number, and you just have to say which is larger. Okay, so it's 2. And of course, we would go like, okay, cool, 3 is larger, right? And then I could do the same with, I'll do the same again. So I'll draw one number, and I'll draw another number, and you just say which is larger, right? And of course, it would be 5. Now you might look at that and go, this is a really easy problem, right? This is a really easy problem. This is something that we could definitely get a computer to do, right? I give it one number, I then give it another number, and it must tell me which number is larger, right? You see, we are making a decision though. So the idea here is that you, as a human, can do this on a very intuitive level, right? You can do this on an intuitive level. But if we want a computer to be able to do this, we need to be able to encode this information in a more meaningful and consistent way. And that's what we're doing with an algorithm. And that's what we do with lots of background noise. Please mute your microphone if you're... So you can see that was a fairly simple decision for a human being to make. But what about for a computer? Okay, so keep that in mind, and we're going to go look at a slightly more technical flowchart. All right, so we've got this one here. Okay, so let's see what this is doing. We as usual start at the start, of course, where with these ovals. We go to the next line. It tells us input X. Okay, X is just a placeholder for some kind of number, right? X is just a placeholder for some kind of number. At the next step, we go input Y. Ooh, there's a little arrow there. Obviously, it's supposed to be supposed to flow. But we go to the next step. We input Y. Y is just another placeholder for a number. We then come to a diamond, and as you guys already know, diamonds are encoding decisions, right? They're encoding decisions. So this is asking us a question, and it'll always be a yes or a no question. Ooh, I should let me add that. Don't know why it's not there already. So I'm just gonna say this is yes. Ooh, it's just hidden. There we go. Okay, so yeah, sorry about that short delay, but Yeah, so now it's complete. All right, so we input X, we input Y, we come to a diamond, which is always encoding a yes or no decision. Okay, so here it looks at X, right? We gave it X and Y, which are two placeholders for numbers. It asks which one's greater, and it makes a yes or no decision. So hopefully what I want you guys to be able to see is that this flowchart is encoding that little game we just played, right? Like what this will do is I'll give it one number, let's say X, so I'll say 3 perhaps. I'll give it another number, Y, and like let's say 4 perhaps. When it comes to this decision, it's going to ask the question, is X greater than Y? Right? So is X greater than Y? X was 3, Y was 4. So the answer to this question is 3 greater than 4 is no. Right? So we would go, in this case, down this no branch. We would output Y, and then we would stop. Okay. So that's a simple use case for where you would use a flowchart, where and how you would use a flowchart, rather. So yeah, again, you can picture this becoming much more complicated if you're doing it if you're performing or creating a more complicated algorithm. But this is quite a simple and effective one. Okay, so this is just, what this will do is just print out the maximum number, right? You give it two numbers, and then it'll print out the maximum number, and then it's going to stop. And for those of you who want to look at it more, you can find this on page 3 of the PDF that was sent on the WhatsApp group. All right. So yeah, with that one done, we can start. So that's flowcharts. They're fairly simple. We'll see a few more examples of them later on in the course. But for now, we can leave flowcharts there. If any of you have any questions, again, feel free to ask. Next, we come to the other decision structure that we introduced a little while ago, and that's decision tables. So I've put a different example here to the decision table that's on page 4 of the textbook. I think this one's as intuitive, also applies to maybe a little bit of a more real world problem. So this is the kind of decision table that we might write for. Clark, it's very loud, the background noise. If you wouldn't mind muting your mic. So so this kind of decision table you would find at an ATM. We do have 11 participants now. So this is the kind of decision table that we would use to create an ATM. So you arrive at the ATM, you specify a certain amount that you want to withdraw. So you specify a certain amount that you want to withdraw. Your ATM obviously has a bank balance, and the bank knows whether or not you are allowed credit, right? So what do we mean by are you allowed credit? It's like, are you allowed to go below 0? Okay, so are you allowed to go into debt with the bank? Okay, and so these are the kind of, obviously perhaps more complicated than this at a real bank, but you can see that these 3 variables, right? These 3 variables are what will determine whether or not you are allowed to withdraw from the bank. Okay, and we can encode this in a decision table. And we can encode this information in a decision table. I don't know why it's not opening here. I can just... So we can encode this in a decision table. We can say, so you arrive at the bank, you have a specific withdrawal amount, and there's a specific bank balance. So if we go to the bank, let's say our bank balance is 500 Rand, right? Just as an example. So if we withdraw 400 Rand, then we can answer this question, right? Or whatever amount we specify to withdraw, whatever amount our bank balance is, we can also always answer this question. What this question is asking is the amount that you are withdrawing less than or equal to, that's what this sign here means. So you probably recognize the less than. If we put an equals to after it, that's how we usually ask the question less than or equal to. So if you have a specific withdrawal amount, let's say 400 Rand, and a specific bank balance, let's say 500 Rand, we can go ahead and answer this question. So 400 less than or equal to 500, the answer to that question is yes or true. Okay, so I want you guys to start thinking about those terms as interchangeable. True, false is the same as yes or no, is the same as 1 or 0. Okay, so at least in programming terminology. So we can answer this question is the important thing. And I would like for you guys to be able to answer this question with any two numbers that you are given. Right? If I give you 600 for the withdrawal amount and 400 for the bank balance, then the question would be 600 less than or equal to 400. So is 600 less than or equal to 400? No, right? 600 is greater than 400. So then the answer to this would be false. You can see, like with maybe a more edge case, let's say our bank balance is 1,000 and our withdrawal amount is 1,000. Is 1,000 less than or equal to 1,000? Yes. The answer to that question is yes, it's true. 1,000 is less than or equal to 1,000. Okay, so we can always be able to answer this question, and it'll always be one of two options, right? It's either yes or no, either true or false. Okay. We can then go to the second question. Is credit allowed? So this is just the bank saying, am I allowed to go into debt? Am I allowed to withdraw more money than my bank balance holds? Okay. And you can see that this is also just a true or false question, yes or no. Am I allowed or am I not allowed to go below my bank balance? Okay. So with the combination of these two questions, we can encode a number of different outcomes. Okay, so let's go through a detailed example. Let's say my bank balance is 500 Rand. The amount I am withdrawing is 400 Rand, and I am not allowed credit. Okay, I am not allowed credit. So those are our three options. Maybe I can say, I can annotate it a little bit. So we'll say that our bank balance is 500. Oh, I don't like doing this because it's so difficult to draw with the trackpad. But yeah, forgive the like 3-year-old handwriting. Okay, bank balance is 500. Withdrawal amount is 400. And I'll say, okay, if I can even manage, we are not allowed credit. That's an N. Okay, we are not allowed credit. So 400 less than or equal to 500, the answer to that question is yes, right? True. 400 is less than 500. Credit allowed? No. So credit is not allowed. So the answer to this question is false, right? We are not allowed credit, so no. All right, so the answer to our first question was true. The answer to our second question was false. Okay, so yes and then no. So how you read a decision table is you answer each of the questions in your columns. In each of your or rows rather. So your first column will have a number of different questions. You answer each of these questions just row by row, and you get whether they're true or false, and they'll always either be true or false. You then go to the corresponding column, right? So you can see this column is true, true. So that's weird, true, false. We're looking for true, false. This is true, true. The next column is false, true. So that's not for us either. So neither of the first two columns are right for us. Then we get to true, false. Okay, so this is the column we are looking for. So once we have found the column that answers both of our questions, we can go to the last row, which will be the answer to your question, right? So what we're trying to find out here is to go, am I allowed to withdraw money if these are, if this is my circumstance, if this is my situation? I'm trying to withdraw 400, my bank balance is 500, I am not allowed credit. Am I allowed to withdraw? So I'll go to the third column, true, false, and the answer will be true. I would be allowed to withdraw in this case. Okay, so you could see, maybe let's look at maybe a slightly more complicated example. Let's say my bank balance is 100. I guess we're not really specifying current. Oh my gosh, that is the worst. I'll even redraw that one. So yeah, let's say 100. Actually, you know what we could do is use the text feature. That might work nicely. So our bank balance is 100. Our withdrawal amount, let's just make something larger than that, something larger than 100. So I'll say 200. Let's just keep it simple. And am I allowed credit? We'll say that yes, I am allowed credit. Okay, yes. So considering this example, again, we just have to interpret the question. So actually, I'll change this to 100 and erase these two guys. Okay, so we again just have to go through and answer all of the various questions. So we'll come to the first question. Is 200 less than or equal to 100? No, right? False. False. 200 is not less than 100. We come to the second question. Is credit allowed? Yes. So the answer to this question is true. Right? We then just need to go and find the corresponding table and the corresponding column in our table. So the first column is true, true, right? We're looking for false, true. So because of this guy, this column is wrong, right? We're not looking for true in the first row. So we go to the second column, false, true. That's correct. We go to the last column, it's true, which means that our withdrawal will be granted. Okay, so I take it, are we comfortable with this idea of decision tables, guys? I think it's not too difficult. So yeah, you just answer each question down the row, and you just answer each question down the row. You find the corresponding column with the correct truth values, and then you go to the last row, which will answer your question. Okay, and you can see another example of a truth table on page 4 of the textbook of the PDF that was sent on the WhatsApp group. But yeah, I hope you guys are comfortable with this idea. All right. Now, why have we done this? Why did we learn these decision structures? Well, as you guys can see, we are making decisions, right? In both of these things. In the flowchart that we saw previously, this flowchart here, we were making a decision about which number was larger. In this flowchart here, we are making a decision about whether your withdrawal at the ATM should be granted, right? But the ultimate purpose here isn't just to encode the decision in like this pretty way. The reason we would do this is to think through a problem, to think programmatically. So remember when I drew out that little game where I was like 4 and then 5, and you just had to say the larger number, you can see that that's quite a simple problem. Why would we need to encode it in more detail? Well, it's because computers, I guess on a fundamental level, are not particularly clever. You have to be very explicit with them. You have to tell them every single step of the problem. And that can even be difficult for a human to decide, right? And I can give you another reasonable example of another algorithm, just to show the point. I'll draw a line. All right, I'll draw a line. It's supposed to be maybe straighter than that, but hopefully for the sake of example, you can visualize. So we've got a line here, right? I'm going to draw another line, and I just want you to say whether the two lines intersect. Okay? So just tell me whether the two lines intersect, like they cut each other. So you can see that they do in this case, right? So here, the answer would be yes, true, right? And we could see that in another example. So I'll draw one line. I'm going to draw a second line, and you just tell me if they cut each other. You can see in this case they do not. Right? They do not cut each other. So you can see that as a human being, this is a very easy problem, right? I give you a line, I give you another line, and you tell me whether you see them cutting each other. But this is a very difficult concept to explain to a computer. Very difficult. You need the equations of the lines. You need their lengths. So this is, you can take my word for it, this is a very complicated problem to teach a computer, whether or not two lines intersect. And hopefully actually you can see for yourselves that this would be quite a difficult problem. It's easy for a human to see, but to explain to a computer how to comprehend this is quite a challenge. So when we approach these kind of problems, what we usually do is we'll encode them in some kind of decision structure like this. And the reason we do that is so that as a human being, you don't really know, and no one does. Like when you see those two lines intersecting, you don't really know how you know, if you understand. You have an intuition about whether or not the lines are intersecting. But if you're asked to explain in detail how you know whether those two lines intersect, it's actually quite a difficult thing to think about programmatically. So, and it's the same with this little example here, right? Like this is just to tell us whether two numbers, like when we give two numbers, which one's larger. You can see that it's actually it's a more complicated decision than what it would seem at first glance. So the reason we do this is to encode what we as humans do just intuitively in a more specific programmatic way that a computer can understand. And the reason we do that is because it's very easy to translate this flowchart you see on the screen, or even that decision table we have on the next slide. So this decision table, it's very easy to program this up. Once you have this structure, it's very easy to program a computer to perform this task. And we do that programming with programming languages. So there are many different programming languages in the world, as I'm sure you're aware, literally, hundreds. And we are just going to focus on one throughout this course. But do realize that programming languages are a tool. All right, you'll be able to transfer a lot of the knowledge that you learn in this course to other languages as well. So before we get into what I want us to do, let me just see, we're only at 9:35, so we should be able to do this before the break. What I want us to do is actually program up this flowchart in C# so that we can at least become exposed with programming languages, because some of you might never have seen that kind of thing yet before, and so I think it's best to just expose you guys to C# as early as possible. But before we do that, we should get a better idea of just the general structure of a programming language, of a file of code, if you like, of some code. So C# has a very intuitive, clever structure. It's a sort of hierarchy almost. So you have this outer piece called a namespace, and I'll explain a nice way to think about this once you see what's inside a namespace. So we have this outer point. Okay. We have these inner things which we'll gain more exposure to later on in the course, because these are actually fairly complicated, but they're called classes. And the word class in the real world is sort of used to mean the same thing. Right, like you have different classes of objects in your mind, right? Like trees, humans, televisions, right? All of these are different classes, and the word class in C# is trying to encode a similar idea. It's like a general classification of thing. Okay. But yeah, that we will keep this abstract for now because later on in the course, chapter 2 deals with these things specifically. And then inside a class, we have what we call fields or properties. And finally, we will get to the point where we actually have our little algorithms, our algorithms and procedures that we've seen in flowcharts and decision tables. This might look intimidating at first, and it should, but as I said, it's best to expose you guys as early as possible to these things, and you'll gain a finer understanding later on. So what is this doing? On a general level, like without understanding all of the specific words, we can already see that it's defining a structure, right? So we've got a namespace, right? A namespace. Inside the namespace, we can have as many classes as we want. And inside the classes, we can have as many algorithms, procedures, and many other things as we want. Okay, so we can say that inside the lesson 4 namespace, we have cars, we have motorbikes, and we have inside cars, we have a method called accelerate, which is just an algorithm. And inside the motorbike, we have a similar method. Okay. Now, again, don't worry. I also think it is a bit scary maybe to be exposed to the structure of a C# program before you've even seen some C#. But I think in the long run, it does play out better to expose you as early as possible to these words, just to get you thinking along the correct track. Cool. So with that exposure done, I do want to get into how exactly we would program up this little flowchart that we saw. So this is the task that we're going to get done today. We're going to create an algorithm where you give it 2 numbers and it just tells you which number is larger. It just says the larger number. So how we're going to do this is obviously we're going to need a place to program in C#. And I think a good quick way to get started on this is with a thing called Rex Tester. Maybe I'll share the link to Rex Tester on the WhatsApp as well, perhaps. But for now, it's in the Zoom chat. In the chat on Zoom, you can find the link to Rex Tester. And this is quite a nice thing. So the first time you open Rex Tester, I think you might have to create an account now, because I think a lot of people have been using it during lockdown because it's a nice way to share code. So any code I write, you guys would be able to see and use yourselves later on, which is quite nice. And also it works on basically any device. So this will allow you to even program on your phones. Usually what we would have done is given you guys like these nice USB sticks, and you would install a thing that you could use on your computer to write C#. But obviously we can't give you those USB drives now. The pandemic has really thrown a wrench into the works this year. But yeah, so we'll be using Rex Tester at least for the foreseeable future. And so if you go and visit Rex Tester, it'll open something that looks like this. I'll make it full screen. So there's this F in the bottom right of Rex Tester, and that makes it full screen. And this is just a C# file. So it's just got, this is where you would write your code. This is what code looks like, if you like. And yeah, it's very simple, very neat. And yeah, you can use it to get started in programming C# very quickly. So yeah, we'll be using this, and you're welcome to open it up yourselves and follow along if you feel inclined. I'll also do my best to share most of the code that we write, although there will be a lot of it, at least in these startup lectures. Cool. So let's contemplate the steps of the flowchart, and we'll slowly build up an understanding of how we're going to translate that into code. I think, yeah, we're going the full 2 hours, so let's hold out on the break a little bit. So we're here at the flowchart, all right? So the first thing we have to deal with is start, right? And luckily, Programming languages have gotten to the point where you no longer need to think about this yourselves. The main method, so this method here, and don't worry, we'll become exposed to this more later on, this kind of terminology more, as you familiarize yourself with things. But this is start. Okay, so in our flowchart, what you see as start is already here in a C# program by default. Okay, so that's very helpful for us. The first step, which is actually a very complicated step, right, telling the computer where things are actually getting started, is done automatically for us by most programming languages. Actually, probably all of them, yeah, all modern programming languages. So that first step is already solved for us, and so we can start thinking about the problem at the second part here. Input X. Input X. Okay, I think it's definitely time to discuss these words inputs and outputs a little bit more. So inputs is just the human, the user is giving something, okay, giving something to the computer. So input X is like saying the human is giving a specific number in our example, like 5 or 6 or whatever, any number that the human likes. Okay. Output is when the computer shows you something. Okay, so a nice way to think about this is the various devices we use for input and output. So for input, a human might use a keyboard, right, to type something into the computer, or they might use a mouse to click on something, right? Those would be user input because you're telling the computer stuff. Okay, output is like the opposite of that. We use screens or projectors, or yeah, like many different things. And that is the computer telling you something. Screen, a monitor is definitely the best way to think about it, but you can think about it in terms of speakers as well, right? Like the computer might play certain sounds that mean certain things, right? Like when you receive a notification, it might go bing, just to tell you that a notification has come through. That's the computer outputting something. It's telling you something, right? So another way to think about it, there is a microphone. That's me giving something to the computer, and speakers are the computer giving something to me, right? So microphone, input, speakers, output. Keyboard, input, screen, output. Okay, so yeah, that's just this idea of input and output. So on this first step, we have to be able to input a number to the computer. Might sound quite simple, right? But you'll see that this leads us down a very long rabbit hole. And that rabbit hole is a discussion of variables. Okay, so a computer saves the things that you give it, right? If you give it a number or a word or a letter or anything, right? Some sound, it saves these things in different kinds of variables. You're probably familiar with the word variable from mathematics, and it's a well-named thing. A variable is anything that can vary, right? It varies. So its value, the thing that it represents, that it is a placeholder for, varies. So it is called a variable. All right? And variables in C#, but in most programming languages, also in most programming languages, look something like this. All right? This is a template for defining a variable. Okay? How I like to put it is that every variable needs two things. Okay? It needs two things. It needs a type and it needs a name. Okay, it needs a type and it needs a name. It also can have a value. Okay, that might be a little bit scary initially, but I'll show you some examples and we'll think about what they each mean. Okay. So here is one example of me taking these things and substituting in a particular variable. Okay, and creating a particular variable. So what I'm doing here, you can see in red, in highlighted, I have int. Okay, int. So int stands for integer. Okay, integer. It's a particular type. It's a particular type that a variable can have. You know what integers are? Negative or positive numbers, right? We can have like 42, 43, minus 2, minus 1, 0. All of these are integers. So an integer variable, if it has int in front of it, that means that it holds numbers. Okay. The name of my variable is number. So I could have made this X, I could have made the name dog, I could have made it Y, I could have made it Z, I could have made it Josh or Brighter or anything. I could make this anything I like, any name I like pretty much. There are a few rules, which we'll discuss eventually. But for now, just think about it. That's when you say number, the computer is going to think about this variable. Okay. Because that's the name we gave it. And we could give it another name. We could have called it name even. So yeah, that's what the name is there for. It's like a placeholder, if you like. And then I say equals 42. So that's just me telling the computer that this particular variable equals 42. So let's explore this example a little bit. Okay, this idea of an integer. See the different things we can do with it. So to start with, I'm just gonna I'm in C# currently as in Rex Tester. So I'll zoom in a little bit for those of you who might be struggling to see a little. I hope you guys can all see. Please, if you want, post in the chat if anything is wrong. Okay, so I'm just gonna put the template here to remind us. So for every variable we create, we are going to have to give it a type. Or a data type, if you like, data type. We're going to have to give it a name, and we're going to have to, and we can give it a value. Okay, equals value. So I'm going to create a few integers using this template here. Okay, so the data type is immediately handled. All right, we have an int. Okay, int. That's our type. That is our data type. Okay, int. So int stands for integer. We know what that means now. I'm going to give my variable a name. And as I said, it can be anything. I could call it number. I could call it X. I could call it Y. I could call it Z. I could call it num. Literally, you could, I don't know, whatever you wanted. Okay, whatever you wanted. So I'm going to call mine X because that's what we use in the flowchart. Okay, so int X. Right, int X. And I could stop there. So there we go. I've created a variable. And you guys might not yet appreciate how important this kind of concept is to learn. But this is how we begin everything. We always need to go, okay, computer, I'm going to give you a bunch of stuff to make decisions with. And you need to save that somewhere. You need to save all of that stuff somewhere. The place where we save that is a variable. And that is how we create a variable. And you'll see it does, like this is obviously a simple example. There are more complicated ways to do this. But on a surface level, this in and of itself already is an important concept, to be able to create a variable. And then I can tell the computer to save things into that variable. Now, remember, I told the computer that it is an int. Okay, it is an integer. So whatever I give it must be an integer, right? If I can give it 8, right? That's an integer. I can give it 9. I can give it -2. I can give it 42. All of these are integers. What I can't do, I can't give it the letter A. Or the word dog. I can't say that int X equals dog. Right? That's not allowed. Because this, as you can see, is not a number. It's not an integer. Right? Integers look like that. So when I told the computer, when I tell C# that this is an integer, it means that the value that this variable holds has to be a number. It has to be an integer. Okay. So there we go. I've now told the computer, I've given the computer a number. Ooh. Was that you, Arthur? Is something wrong? So we've got our first number. All right, our first number. That's in a way the first part of our little flowchart, if you guys recall. Okay. So we've done that first step now. Okay. Before we move on with creating that flowchart, I think we will digress a bit and discuss the different ways we can create variables and the different types that variables can hold. That'll give us a better fundamental understanding of variables, and then we'll be able to come back and get on with creating that flowchart. For now, though, we have been going for a good 50 minutes, so I think it's a good time to take a 10-minute break. So we'll come back probably at something like 10:05 rather than 10:03, because that would be a weird time. So yeah, we'll come back around that time. Please, if you have any questions during the break or wanted to discuss anything specific, then please do bring it up. I do actually want to mention something. I do want to ask the class. So please post in the chat what you think of this. So with our other classes, we also started with these 2-hour sessions. Most people agreed that 2 hours was a little bit long, particularly for an online lesson. Like in person, it's much easier to interact and keep interest. So what do you guys think? Is C# similar to Java? I've been asked. Yeah, I would say so. They're both what we would call object-oriented programming languages, as opposed to another thing called functional programming languages. And yeah, these are great questions, guys. So yeah, please do ask them. And yes, C# is quite similar to Java. A lot of similar structures. I would say C# has some extra things, but remember that's not necessarily good, right? Adding extra words to your programming language makes things more complicated, right? So it makes it more complicated to use. So sometimes simple is best, but yeah, C# is similar to Java. But there is a lot of ways to unpack that question. But yeah, on a surface level, definitely. Which is good, because I understand a lot of school IT programs are run in Java. So if you've ever done one of those, you might be more familiar with this than you otherwise would be. Anyway, yeah, so please, guys, tell me what are your thoughts on the 2-hour session. Are you okay with the 2-hour session? The alternative is for us to do 1 hour and 30 minutes, and for me to give you some like extra reading or an assignment during the week, where you can do that last 30 minutes. So please, guys, do let me know in the chat what your thoughts on that are. Do you prefer a long 2-hour session or a 1 hour and 30-minute session with some extra reading or something like that, so that we can get into a more consistent flow? Cool. You don't mind either. You prefer the 2-hour session. Okay. Cool. Awesome. Then yeah, for now, and yeah, so we'll do it by vote, I suppose. So yeah, for now we'll be sticking to the 2-hour session. That's cool. Awesome. So yeah, we'll get started again at 10:05, and we'll. So yeah, I'm just gonna go and grab something to drink quickly because I'm a little bit thirsty. So I'll be back now. Cool. Yeah, seems like most people prefer the 2-hour session, so we will be sticking to that then. Awesome. So let's get started again. So we are continuing with our discussion of variables. So we've seen one variable type, int, right? Int. And we've seen sort of how to use this this simple template here to create an integer. But it is more complicated than that, of course. There are many different variable types in C#. We will in particular be dealing with 9 of them. Okay, so int is one. So don't let, and you'll see that the reason we have all of these different variable types is quite intuitive, actually. And also you don't really have to think about all of them. Some of them you just remember the names, and some of them we'll use quite frequently. Okay, so let's just create a few other variables and cover just the main useful types. Okay, so int is definitely the one we'll probably gain the most exposure to. So int is the one we'll gain the most exposure to. We'll use ints a lot. Second to that is a thing called a string. Okay, strings are quite interesting. A string, it's probably the worst named data type, I think. But basically what you can see it as is a set of alphanumeric characters. It can also hold special characters. So a number is pretty easy for a computer to grasp, right? But like if we have a word or an @ sign or exclamation points and commas and spaces, things become a little bit messy. So I first want to gain a bit of an intuition about why strings need to exist in the way that they do. Okay, so let me explain it this way. So just take a look at the C# program. It might look a bit gibberishy for you guys right now, but don't worry, we'll gain a lot of exposure to this kind of stuff. But I just want you to look at like one line, and you can pick a line because it'll always be true. But I'm gonna think about this line here. Quite a long, complicated line. Okay, that we've got here. Notice there are a bunch of words here. We don't know what they mean yet, but we will eventually. There is public, static, void, main, string, args. There's also some square brackets here. There's a lot going on this line. I think you can agree. The main thing that concerns us right now is like these words here, right? We've got the word public. And you can see that Rex Tester has gone and highlighted this word in purple, right? So, and you can see it's done that with a few words: namespace, using. It highlighted int in purple. You can see that a lot of things are highlighted in purple here. What that means is that C# recognizes that word. Okay, so that means that that word is what we call reserved. It is a reserved word. Public has a specific meaning in C#. Static has a specific meaning in C#. Void has a specific meaning. Namespace has a specific meaning. Using has a specific meaning. Int has a specific meaning, and we know what the meaning of int is now, right? It means that this is a data type that holds numbers. So you can see that various words have specific meanings. Ooh, someone has some background noise, please. So all these words have particular meanings, okay? But you can see that they also have English meanings. Like you can picture a program where you want to use the word public, but like in a literal way. You want to, I don't know, print to the screen. You want to show your user, you want to print out public, right? Like this is public information on your website, for example, right? You can picture that we might want to use the word public occasionally. But you can see if I just type public, it's immediately highlighted in purple. C# is going, oh, this has a specific meaning. I know what this means. You have to use it in the way that I expect. Okay? The thing that allows us to get around this, the thing that allows us to get around the fact that there are certain reserved words is what we call a string. Okay, what we call a string. So let me give you an example. What we're going to do is we're going to create a variable of type string. So you can see we've created a variable of type int at the top there. And I'm just going to create another one. And what I want you guys to see is that it's very similar. All right, it's very similar. So I'm going to type string. And you can see it's immediately highlighted in purple. It's a reserved word. It has a meaning. Okay. And so far, it looks pretty similar to this first line here, right? We had int here, that was our type, and here we have string, that's now our other type. Okay. The next thing I hope you guys can expect, all variables have this same template. They're created according to the same template. We give a type. The next thing we have to do is give a name for our variable. So I'm going to say, I'm going to call mine word. Okay, string word. So the type of this variable is string, and its name is word. And again, I could have called it anything I like. I could call it Z, T, W, right? I can give it a lot of different names. Any name that is not reserved. So I'm going to call mine word. And you can see word is not highlighted in purple. C# does not assign a meaning to that word. Okay? Or to that thing. And you can see I could call it W as well. What I want you guys to understand is that it doesn't matter what I name it necessarily, as long as it's not reserved. So I'll call mine word, just for it to make sense. And then the value. All right. So just like with int, remember with int, we had to give it a number, right? I could give it 0, I could give it 8, but if I gave it the letter A, C# would complain. That's not allowed. It's an int. It has to hold an integer, right? So you can give it any integer you like. like even long ones, that would be fine. Any like long integer, right? And string has a similar kind of restriction. You have to give it a string. So I can't, like, if I type 8 here, this will break, right? So int, it's allowed to be 8. String, it would break if I said 8 here, right? It would break even if I said G, or if I typed, I don't know, let's use a string. The one I'm using in the slide is Ali. So if I type that here, that will break because this is not a string yet. How we define a string in C# is we put it in quotation marks, like that. Okay. Now, what's happening here? I want you guys. It's an important thing to appreciate, so I do want to spend some time on it to make sure everyone gets it. Is the reason this is in quotation marks, right? This is just a random word. It could be any word. Let's say it was public, for example. Let's say I want to use the word public. So I'll say, I'll use the word public here inside the string. Okay. The reason it has to be in quotation marks is because if it's not, you wouldn't be able to use reserved words. Right? So like I want to be able to use the word public, even though public has a meaning. And so when I save it in a string, I put it in these quotation marks. Okay. So I hope you, and you might go like, okay, cool. So that allows us to use some of these extra words, but it's actually more important than that. Let's say I want to save in my string. Remember, it can hold any alphanumeric characters. That includes spaces, at signs, exclamation points, hashtags, ampersands, all of them. Okay. As long as they're in these quotation marks, they're not going to cause problems because the computer will not read anything in these quotation marks as code. It just sees it as a bunch of text. Okay. But what I want to show you is just how important this is. Because like, let's say I wanted to use the word public and you agree, cool, that's important. We have the quotation marks to allow me to use the word public. But even something as simple as space, right? So you see I've just got a space between the two quotation marks. Space is a character, right? And actually, space has a meaning in C#. Just space, a very simple character, but it has a meaning. You can see here I have public, space, static, right? That means that if I just randomly put a space at the end here, this is like C# would not be able to save a space because space is like, you know, it's separating things from each other, these words, right? So in order to save anything, in order to save any special character that has significance, we put it in these quotation marks to differentiate it from the standard words, right? So a good example that we've already dealt with is public. Okay, public. See, it has a meaning, but when it's in these quotation marks, C# doesn't read it as if it's code. It just reads it as a word. Okay. But the important thing is string. A string is a variable type that can hold all of these different alphanumeric characters and everything, and it's not read as code. It's just read as text. Okay, so like if you wanted to save an email address, you would save it in a string. Okay, so that's now two data types that we've dealt with. And you can see that the computer requires us to be very specific, right, about what it is we're saving, what it is we're using, and how we're using it. Okay, so this is an important idea to get across is how we use this template to create all of these different data types. Okay. So what we know now is that strings have to be, the value has to be inside quotation marks, okay, for it to be considered a string. Cool. Let's look at a few others. I know it's probably, I get that this is a bit overwhelming. Remember, we would usually cover this over multiple weeks and slowly go through each one. But I do want to get all of these little technicalities out of the way so that we can focus on, you know, the interesting, more more conceptually difficult stuff rather than just these definitions. Cool. So there we go. We've got now two variables that we know how to use, two variable types, I should say, int and string. And you can see they're defined according to the same template. In this case, our two variables, you agree, these lines look very different. But what I want you to see is that they're using the same template. They've got a type, right? The type of the first one is int, the type of the second one is string. They've got a name, x, and word, and they've got a value, right? And the value looks very different because the type is different, right? The type and the value have to correspond. But you can see that they're the same templates. And let's look at one more. Okay, let's look at one more. So another variable type that maybe will help you gain some intuition of how computers think as well is called bool. Bool, like that. I think it might be useful to check out the formal definition of the word Boolean. Boolean define. Denoting a system of algebraic notation used to represent logical propositions by means of binary digits. 0, false, and 1, true. That's the important bit, this little bit here. Binary digits, 0, 1, 0, false, and 1, true. Okay, so what bool means, bool stands for Boolean. Okay, and it just means that it's one of two things. It's either true or false. Okay, so we can give a simple one here, the same one we use in the slides. And remember, what's important here is for you guys to get that it's created according to this template. So the type is bool. The name can, again, be whatever you want. I'm going to call mine understand, but you could call it whatever you liked. Okay, so understand. And then we have an equal sign, as we do in the template here. Equals. And now we have to give it the value. But we have to decide on what is a Boolean's value. And a Boolean's value is just either true, and you can see true is a reserved word. Okay, it's either true or it's false. Okay, true or false. Okay, it can't be anything else. If you try to make it F, that's wrong. The computer will complain. That is not a Boolean. You can't make it K or public or anything else. It has to be Boolean, which means it's either true or false. So this is a variable type that can only hold one of two things. It's either true or it's false. Okay. So there we go. We've immediately seen three different data types, and you've seen how easily they can be used, right? How easily they can be used. Now, get prepared. The next slide is going to be a lot, but I just want you guys to get an overview of why we have all of these different types, why they need to exist, what it is they all do, and just a basic understanding of why they all exist. Don't worry, we'll be exposed to them all a lot more down the line, but I just want you guys to get to grips with all of these different types, and then we'll continue with that flowchart example. So, page 9 of the PDF that was shared on the WhatsApp group is where you can find a lot of this stuff. There's a table on page 9 of that PDF, and it's not particularly meaningful, so I've created like our own little chart here that will hopefully put things into perspective a little bit more. So the different types are used to hold different things. Okay, hopefully I hope you get that much so far. The different types are used to hold different things, different types of things, right? So we have types that hold numbers, for example, right? We have types that hold numbers. Just to make sure that someone's still concentrating, what is one type that we've seen that can hold a number, right? We've seen three types so far. What would you say? Can anyone post in the chat? There we go. Yeah, 100%. We've seen an int, right? That's probably, and that is probably the most important example of one that can hold. Cool. So yeah, two people. Awesome. Yeah, you guys are on ball. So yeah, ints will hold numbers, but there are other ways we can hold numbers as well. Okay, so there are also a thing called a short. There's also a thing called a short. Okay. And there is also a thing called a long. Okay, short and long. Now, immediately, like without even knowing the technicalities of this, what I want you to appreciate is that these are very well named. Okay, we've got int, okay, that holds integers, right? 4 bytes, okay? We'll discuss these sizes a bit later, but the point is this holds integers, so negative or positive numbers, okay? Short also holds negative or positive numbers, but they're short numbers, okay? So it can hold shorter numbers. Long can hold longer numbers, okay? But you can see short uses the least space, but can only hold short numbers. Int uses slightly more space, can hold longer numbers. Long uses a lot of space and can hold really long numbers. So to be more specific, again, you can see this on page 9 of that PDF. Short can hold numbers between negative 32,000 and a bit and positive 32,000. Int can hold numbers between, and these are big numbers, between negative 2.1 billion and positive 2.1 billion. Long can hold numbers between 9.2 trillion or negative 9.2 trillion and positive 9.2 trillion. Okay, actually, I think I might be underplaying it there. 1, 2, 3. Let me think about that. 8 times 3. No, I think it's actually more like 9.2 septillion. But regardless, the point is gigantic numbers can be held in longs. Okay, I do need to, let me think. 9 million, 9 billion, 9 trillion, 9 quintillion, 9, I think that's called sestillion. 1, 2, 3. I don't know why I forgot this. Let me just Google it quickly. Yeah, sorry about that. I just forgot. I think it is called sestillion. Sextillion. Okay, sextillion, yeah. Okay, cool. That's what it's called, sextillion. So 1,000 raised to the 7th power. So that it can hold up to 9.2 sextillion, which is gigantic, obviously, gigantic. And you don't have to remember the specific number. The point is just very big, okay, very big. So long can hold very long numbers. Okay, so an example of a thing that can be held in any of these data types is 42. Okay, 42 can be held in a short, an int, or a long. In general, we'll use ints because it's like a good middle ground, right? We aren't frequently going to be holding numbers larger than 2.1 billion. We won't be working with numbers larger than 2.1 billion, probably. If we were, then we could go ahead and use long. But you can see it takes up more space, okay? And for now, just that's a healthy intuition to have about it. The larger variables use up more space, okay? So there we go. The other thing, though, is notice that 42, right, has no decimal places. It has no decimal places, right? So, like, let me explain this in Rex Tester, rather. You can see I can say int x equals 8. That's allowed. I can't say int x equals 8.01. Okay? This is an integer. And if you guys recall from just maths class, integers are like numbers without decimals. Okay, they are like whole numbers mean something else, but you know what I mean. They're like whole numbers. They're integers. Okay, so they don't have decimal places afterwards. So like 8 is an integer, 9 is an integer, but like 8.5, that's not an integer because it has this 0.5 afterwards. Okay, so ints, longs, and shorts are not allowed to have decimal places. So we need a different type to hold a decimal place. Okay, and we have another 2 data types that can do that. So decimal numbers. Another 2 data types can do that. Now, if you are, I don't know if you guys have heard this term before, but we often call like the decimal part of a number. So let me explain it like this. if like we have 8.0, some long decimal thing here, we often call these like floating points. Okay. So this is actually quite well named. Okay. A type that can hold decimal numbers, so numbers with decimals afterwards, is called a float. Okay, float, because it can hold the floating points as well. So, for example, I can't say int x equals 8, but I can say float, and you can see it's highlighted in purple. C# knows what it means. Float y equals 8.5. That's allowed. That is allowed. Okay, so that can hold decimal places. Pretty simple. Again, there are a lot of types to remember, but you can see it makes sense why they exist, right? There'll be a case where I only need to hold very short numbers, so I can use less space. There might be a time where I need really, really long numbers, so I'm willing to use more space to hold those really long numbers. So you can see there's reasons why these exist, and there's reasons why floats exists. But, like I said, there are two ways to hold numbers with decimals afterwards. There is float, but there is also one called double. Now, an interesting thing here. So, let's say I'll do an example that a lot of people maybe could get. So let's say pi. You know what pi is, right? We've got like it's 3.14159. That's as far as I can go from memory. But whatever. So we've got pi. The like number of decimals after after the decimal point is often called the precision of the decimal number. So like, you know, pi goes on forever, right? Like it has an infinite decimal expansion. So it goes on forever. Like this is just 5 numbers, like a pretty good approximation, but it goes on for very long. Okay. So floats can only hold to a certain precision. So maybe they could go to, for example, 3.1415, for example. Okay. Doubles, the reason they're called doubles, is because they have double the precision of a float. Okay. So, for example, if the float could go to 3.14, then the double could go to 3.1415. Okay. Just as an example. That's an oversimplification, but just to get the idea across. So if you need very precise decimal points, so like more than just like 0.25 or something like that, if you need very precise decimal points, then you can use a double. So it makes sense why it exists, and the name makes sense, right? Double the precision of a float. Okay, and yeah, for example, a decimal number that either of these could hold is 3.14159. Okay, so that covers the numbers, right? We can now hold numbers without decimal places and numbers with decimal places. And we have a bunch of different types to choose from. Okay, but you've also seen another type, because what if I want to hold words, right? Sometimes I'll want to hold, for example, people's names or names of different cities or something like that. I might want to hold different kinds of words. And those we call like alphanumerics, because, right, it's not just words. There's also things like full stops and @ signs and hashtags and exclamation points and brackets. All of these things fall in this category, and also numbers themselves, right? Like, I hope you guys can already gain some intuition about, like, so here we have int x equals 8. If I say string word equals 8, that's not allowed, because 8 is an integer. So it needs to be held in something that is of type integer, right? But I can do this. I can say 8 inside quotation marks, because putting it inside the quotation marks makes it a string. Okay? So strings can hold any alphanumeric characters, right? And you've seen that already. So a string would fall under this. There is one other data type that can also do this that's much simpler, called a So for example, a string we've seen it can hold like words, mouse. It can hold special characters as well, josh@email.com or anything like that. But there is a simpler way to do it as well called a char. A char. And char just stands for character. Character. Char just stands for character. And chars will just hold singular characters, like the letter A or the number 5 or an @ sign. Okay, just one. Only one. So let me give you an example of that. Like so we've got our string that can hold multiple characters, right? And so I'm making it random intentionally. Like this is a very crazy string, but this is totally fine. C# will be happy with this. That's a string. It's a legal string. I can put spaces in there, all these different characters. A char can hold all of those same characters. So I can say char, and I'll say letter, for example. I'll call mine letter. Again, though, the name doesn't matter. Hopefully you remember. A char will just hold one character, and we put it in like these single quotes. So it could hold an @ sign. It could hold A. It could hold 7, right? It could hold an exclamation point, anything you like. But it couldn't hold two of them. So it couldn't hold exclamation point 6 or exclamation point space or 77. That wouldn't be allowed. Or 76. That wouldn't be allowed. A character can only hold a singular alphanumeric character. And spaces do count, dashes count, underscores count. All of these count as one under alphanumeric character. Okay. So that's what chars hold. Just singular alphanumeric characters. So hopefully that makes sense. So you can kind of see a string is like just a lot of characters, right? A string is like a string of characters. And that's where its name comes from. Okay, so hopefully that makes sense. So those are the two ways we can hold alphanumeric characters. You can put them in a string, which means you can hold lots of them, or you can put them in a char, which means only one at a time. Okay, one char can hold one character. All right. So, the last data type that we have also seen is called a Boolean. And Boolean is quite simple. It just holds true or false. Okay, only that. It's either true or it's false. Okay, and that makes sense that computers would have something like this, because you guys have probably heard of binary before. Like computers think in a bunch of ones and zeros, if you like. Think is probably the wrong word. But yeah, they like machine code is in ones and zeros. And so like a Boolean is just a pretty high level way of representing just a singular bit, right? Like it's either 1 or 0. It's true or false. All right. And so that is all the types. That's all the types you guys need to know. I know introducing them like this wouldn't be ideal. We would like to go in depth with every single one. We do not necessarily have the time for that. But for now, hopefully what I would like you guys to have is just on an abstract level, an idea of the reason all of these different types exists, or all of these different types exist, what it is they hold, what it is they're used for, and we'll slowly expand our understanding of all of these. Cool. We've got about 24 minutes left, which will be enough time to go ahead and program up our decision structure, our flowchart. So I'm going to jump back to this flowchart, and we're going to think about what we've learned so far and how it applies to us creating this flowchart. Okay, so currently we've learned about these first 2 points here, input X and input Y. We've learned about what X and Y are for the computer, right? X and Y would be integers, or shorts or longs or doubles, any number really. But in our case, I drew out 5 and 4 and 3 and 2 when we were doing that little game at the beginning. And for those, we would use integers, right? We weren't considering decimals. Hopefully you see how we could if we wanted to, but we're not going to. Okay, so x and y for us are just integers. So hopefully we have a better understanding of how these first two steps are going to go down. Okay, we're going to create an integer x, and we're going to save a number into it, an integer. We're then going to create an integer y and save a number into it, an integer. Then we get to this diamond here, right? And this is really the crux of programming, if you like, right? We have a way of giving facts and figures and numbers to the computer in variables. And eventually, in any programming problem, we're going to get to a point where we want to make a decision, where we get to one of these diamonds. And so now we have to talk about, all right, how do we use this data to actually make a decision in C#? How do I actually ask a question? How do I ask, is the number in x greater than the number in y? Right? That's a yes or no question. The number in x is either greater or smaller than the number in y. It's a yes or no question. They can also be equal, but you can see that would be a part of the yes or no question. Like this is greater than, so it doesn't include equal to. Right? Greater than or equal to is a different question that we saw during the withdrawal in the decision table. Right? So currently, if x was equal to y, the answer to this question would be no. Right? Because if x is equal to y, then x is not greater than y. Right? So the answer would be no. So it's still a yes or no question is the point. Okay? So how do we actually ask this yes or no question and do this split? You can see we're splitting into two possible solutions. How do I do that in code? How do I tell C#? How do I explain to the computer how to do that split? And so we're going to come to the first and probably the most powerful way to make decisions in computers. It seems very silly, but you'll eventually see that by stringing a lot of these together, we'll be able to make very, very complicated decisions. Okay? And these are called if statements. If statements. So they are the first statement that we will be learning. And yeah, there are a lot of statements in C#, a lot of different words to learn. It would be overwhelming to tackle them all at once like we did with the data types. So we are going to go through these one by one, and I think it's definitely useful to do so. So that diamond, right, that yes or no question, this is how we would display it inside C#. Okay, so you have an if, the word if, the English word if. You ask a question. You ask a question, and then it's either true or it's false. Okay, either true or false, yes or no, 1 or 0. Okay, so we've got this way to encode this decision. All right. We are going to use this statement now to program up that flowchart to tell us which of our integers is larger. So I'm going to come into Rex Tester currently. I'm going to remove all of these other data types we were creating and playing with, because right now all we need is ints. Okay, I'm also going to remove by the way, this little thing at the top here is called a comment, right? If you put // you can see everything turns green. Okay, that means that that's just not read as code. Okay, this is just like some notes. So I can make it green by putting the // and I can make any notes that I want, and C# isn't going to read it as code. Okay, so but for now I'll remove those comments. We'll discuss comments in more detail eventually. Cool. So right now we've got int x equals 8. All right. So that's one integer. Right, so we've done the first step on our flowchart. We've created x and we've given it a value. Okay. The next step is to say int y equals, and you can make this number anything you want. I'm going to make mine 6. Okay, 6. Okay, int x equals 8, int y equals 6. Those are the first two steps in the flowchart. And what I want you guys to see is that it's very it's sequential. It looks a lot like the flowchart does, right? Right, we've got our start statement. Remember I told you that this main bit here, that's C#'s version of start. We then have the two steps. And the next step is the diamond, right? The next step is that diamond where we ask the question, is x greater than y? And we get that yes or no response. And the way we ask that question is exactly like this. If we put the question inside these normal brackets, the answer if it's true, the answer if it's false. So I'm going to run through a few possible ways we could organize this. So let's say we were asking the question, is num greater than 6? Okay, num can be an integer, right, holding a specific number. And so all this would be saying is the number inside this integer greater than the number 6. Okay, again, it's a yes or no question, right? It's a yes or no question. So if the answer is true, right, so yes, that would mean that number is greater than 6. Then we could say, like, if we get here, we would say that num's value is greater than 6. There is this other possibility, though, and for that we have the word else. So if this is the case, then do something. But in other cases, elsewhere, if you like, in other possibilities, num's value is less than or equal to 6. Okay, so we had true or false, right? True would mean that num was greater than 6, so num's value is greater than 6. In other cases, num's value is less than or equal to 6. Right? So you can see that there's this yes or no branching here. Right? And there are different ways to ask this question. So there are a lot of different ways to ask C# questions like this, and we're going to cover those in detail as well. They're on page 10 of the PDF shared on the WhatsApp. We'll probably only get to them next week. But one simple one is equals equals. So if you put equals equals, this is like asking the question, is the number inside num, so this is a variable, an integer, equal to 6? If the answer is yes, then num's value is equal to 6. Else, so in other cases, num's value is not 6. Okay? And hopefully you can also see that we don't need the else statements, right? Like maybe we just don't care. If the answer is no, we just don't care. And so we could leave out the else and just have if. Okay? But let's discuss our example now in more detail. So our example was this flowchart. We have a very simple question to ask. We want to ask, is x greater than y? So I'm going to zoom in a bit, just so that you guys can see very clearly what's going on. I'm going to type the word if, and you can see it's highlighted in purple. C# knows what I'm doing. That's good, right? Like, as you type, the computer will make sure you know, like, okay, I'm able to follow what it is you're doing. I'm going to put these two normal brackets, and inside these normal brackets is going to be our question. Okay, we haven't thought about this yet. For now, I'm just going to say question like we have in the slides. That's where we're going to ask our question. Okay. I'm then going to put curly brackets here. Okay, open up two curly brackets. All right. Now what this means, if the answer to our question is yes, then the computer will do whatever I say inside these curly brackets. So will do this if true, okay, / yes, okay. So if the answer to the question is true, it's yes, it's 1, then we will do whatever is inside these curly brackets. Okay, so this is like in our diamond, in that diamond decision structure, this is the branch that said yes. Okay, everything that must happen in the branch that said yes is what we'll put inside these curly brackets. Okay. We then have, say, else. Okay, else. So this is like elsewhere. In other cases, basically when the answer to the question is no or it's false, then it will run whatever is between these curly brackets. Okay, so this is like the no branch of our flowchart. Okay. So now we've got this basic template outlined, we can actually go ahead and translate that flowchart into C# code, and you'll see that it looks very familiar. So yeah, I'll even make the similarity clearer. What I'm going to do is I'll put a comment here saying start. So this is where we start running the code. We have step 1. Let me go back to the flowchart so that you guys can see it side by side. This is the problem with having slides with too many animations, is you have to skip backwards through them. Okay, so here's our flowchart, right? We have start, we have create a variable x and give it a value, create a variable y and give it a value, right? You can see our code is doing exactly this in the exact same order. We just have to do it in the way that C# understands, right? So we create x, we give it a value, we create y, we give it a value. Cool. Next, we get to this decision structure, right? We're asking a question. Is x greater than y? And you can see in the flowchart it's got a question mark after it. This is our question, x greater than y. And you can see we've got this structure here, which we say defines a diamond, that diamond. So I'm going to ask the question here. Is x greater than y? Is x greater than y? Cool. And now we just need to fill in each branch, right? We just need to fill in each branch. So the answer to our, what do we do if the answer to the question is yes, if x is greater than y? So let's go ahead and look at the flowchart. If x is greater than y, so x, the number held in x is greater than y, then we follow the yes branch. And what it wants us to do is output x. Output x. Okay. Now, slightly new thing, but it's pretty easy to follow, I think. But so output x is just saying I want you to print x to the screen, right? So whatever number is held within x, I want you to print out that. Okay, I want you to show the user that number. How we do that in C#, and this is an important thing to get. The flowchart is not program like language specific. Okay, the flowchart is the general way that we think about the problem. It has to be translated into code. Okay, it has to be translated. So it says output x. What it's saying is I want you to print x to the screen. It doesn't care what programming language you're doing this in. I can translate this flowchart into any programming language, any one that I like. It's not programming language specific. It's a general way to think about the problem. So it's telling us to output x. How do we do that in C#? We'll use a specific method, a specific thing called writeLine. writeLine. So I'm just going to type it out. Might look scary at first, but it's doing something very simple. And you'll see what it does at the end of this. So what I'm going to say is console.writeLine console.writeLine. So all that's saying, you've heard of reading and writing before. So writing is just like when the computer puts something somewhere, right? It writes it to the screen, or it writes it to your desktop, or something like that. Okay, and this is just saying write a line. So it's like print out. Just print this to the screen, just put it on the screen. And you'll see what effect that has in a bit. What do I want to print to the screen? It said we must output x. So I want to console.writeLine x. So that's just going to print x to the screen. Okay. Cool. So we've dealt with this yes branch. Now we need to think about the no branch. So what happens if the answer is no? That would mean that y is greater than x, or that they're equal, right? In that case, we follow the no branch, and we must print out y. Okay, output y. So print out y. And we know how to do this already. We've done it with x. So now we just come to the no branch, and we say console.writeLine y. Okay. So we've dealt with both of our branches. and then it says stop. And luckily, C# handles that for us automatically. So you could think about it like this, it's stop, but C# does it automatically. Remember, the green stuff isn't actual code. We don't need the stop, we don't need this, okay? We don't need it. I'm just showing you that it looks very similar to the flowchart, right? So yeah, that is it. That is translating. So this flowchart looks like this in C#. Okay. And now we can see what it does. So I'm going to zoom out a little bit. Minimize the screen. Now in Rex Tester, once you've written up some code like this, assuming you didn't make any mistakes, which it's easy to make typos, obviously. But you can click run it, right? You click run it here, and it'll then run the code, and you can see our code prints out 8. Prints out 8. Now, does that make sense? It does, right? It said we gave it x, 8, x equals 8, y equals 6. It went ahead and asked the question, is x greater than y? So these were placeholders. So it took x, replaced x with 8, replaced y with 6. So it was asking, is 8 greater than 6? The answer to that is yes. So it came to the first branch, it printed out 8, and then it went ahead and stopped. Okay, and you can see it printed out 8. We can try this with some different numbers, right? Like let's, instead of 8, let's say 5. Okay, what should it do now? It should print out 6, right? We want it to print out 6. Because it'll say, we say int x equals 5, int y equals 6. Is 5 greater than 6? No. So it goes to the else statement, and then it prints out 6. And you can see it works. It prints out 6. Okay. So what we've managed to do here is translate this flowchart into C#, which is a good start. A good start. So cool. We used if statements to do this. We use if statements to do this. All right, the next thing we would be discussing is basically a more complicated kind of variable. We do not have time to do it in the next 6 minutes, I don't think. So I think we should save that for next week and call this a little bit early. I was expecting more questions, but I suppose that's good. Hopefully that means you guys understand and not because you're worried about anything. But yeah, I think thank you for coming, everyone, and yeah, I'll upload this to YouTube and share it on the WhatsApp group. So I'll add it. All the lectures will be added to a long playlist, and you'll be able to a YouTube playlist, and you'll be able to go back and revise anything that you're not comfortable with at any point. Let me stop sharing my screen quickly. So you'll be able to go back and revise any part of the course that you're not feeling comfortable with. We'll also do normal revision sessions. So yeah, I suppose, and we will be sticking to the 2 hours. It seems like you guys would prefer to stick to the 2 hours, so we'll do that. So I'll see you next week, Saturday at 9 to 11, same place. And yeah, thank you for coming. If there's any questions, you can feel free to ask. And enjoy the rest of your weekends. And yeah. No problem, no problem.